All right, so we're up to more of Android internals, and then I'll demonstrate several projects. That's the plan. And someone said I had to deal with this today. Okay, but anyway, there's no more details there. So let me get this big enough. That'll do. All right, so we did the first part of this chapter. We're doing the second part. I broke it into 3 chunks. So here we're talking about the security model of Android. Yeah?
Is there a page number that I can tell which part is first part of chapter 6?
Yeah, it's here.
Second part of
Yeah,
chapter 6?
yeah, it's here. Yeah, what we're doing today is from 205 to 222. Yeah.
With the O'Reilly reader, there's no way to turn on page numbers apparently.
If you have the Kindle version, there may not be. That's why I also gave the labels of the sections. So you'll find these labels in like the table of contents. Yeah. A good question. Anyway, so here's the topics we're going to do: code signing, permissions, the sandbox, and encryption. These are the aspects of the Android security model. So very important to us. This is how apps are protected from other apps. So that's the security model, and the idea is no app should be able to access the data in another app without proper authorization. It should be open and extensible, and Android must know who created an app, at least to know whether Google made it or not. So code signing is here. You have digital certificates. Digital certificates are a cryptographic identity card, and you can generate them with KeyTool and sign your app with Jar Signer. We'll do it in the project. Now, normally, to get a code signing certificate, you have to pay money. It's about $100 a year. You have to get it from certain companies. And then your code signing certificate will be validated by third parties on the internet. But for Android, you can use self-signed certificates, which are not verified by anybody else. So they don't prove anything about your identity. The only thing they prove is that the person that signed this app holds the private key for that certificate. But if you were to sign an update or another app with the same certificate, they can tell this is from the same developer. They don't really know who you are, but they can tell if 2 things came from the same developer. That's the only thing the certificate does. So, for example, if you take the Progressive Insurance app, we'll do this in the project. When you suck it off the phone, it's called base.apk. So APK tool can disassemble it with D. That breaks it up into its pieces, pulling out the images and code and everything inside there. And then you have a series of folders. So if you go in here to the meta.inf folder, you'll find the certificate in there. It's a file. You can't just print it out. It's not a plain text file, but you can open it with KeyTool and print certificate. And you'll see here, Matt Lehman is the person who signed this, somebody from Progressive Insurance. Here's the fingerprint and the algorithm and so on. And then you can use another tool to see it in a more familiar form called OpenSSL. This will show you the certificate. And here you see the layout the way you'd see it if you go on the properties sheet of a browser. Goes across 2 pages. And the certificate is actually this blob of binary in base 64, but if you open it, you can see the private key inside there, or the public key inside there, not the private key. Anyway, that's what the certificate looks like. And this certificate is from Progressive, but I think it's probably self-signed. I don't think it's actually signed by a major certificate authority. And so, but an interesting issue is whether hashes are good enough. It's using SHA-1 hashes, and some people don't like to use SHA-1 hashes because there are some collisions in SHA-1. About 10 years ago, Google developed 2 files that have the same SHA-1 hash, even though they're different files. So that's not a perfect hash function, but it turns out to be good enough for the purpose we're using it for here. It's the fact that you can carefully craft 2 files that have the same hash does not mean you can take an arbitrary file and create another one with the same hash here. You can only do it by creating 2 files that are closely related. So the fact that there are SHA-1 collisions does not mean that you can forge this certificate. The only time that has ever been done successfully is at DEF CON. They actually managed to forge an MD5 based certificate, but no one's ever managed to forge a SHA-1 based certificate. Although you could argue that they really should be using SHA-2, but anyway. All right, Android doesn't verify the certificate in any way. All it does is verify that the app has not been, it verifies that the app has not been altered since it was signed. It includes a hash. It calculates the hash of the app, makes sure it matches, and that's it. It doesn't go any further. It's self-signed. And so Google recommends that you make your certificate valid for 25 years, because if your certificate expires, you won't be able to update the app. The Android operating system will refuse to have the update because the certificate is no longer valid. And right, so there have been some signing vulnerabilities. all these things have flaws. Here's 3 famous vulnerabilities in Android signing. The master key is a very simple vulnerability, although versions of this keep happening. The APK is a zip archive, and you can put 2 files in there with the same file names. And if you do, the first one is the one that's used to check the hash, but the second one is the one that actually gets installed on the device. So therefore, you can sneak something in, you can modify it without it changing the hash. There's the kind of error that happened. There was another one of these that happened last week. There was an Android malware that changed the header of the zip file so it was invalid. And what happened is the Android operating system would still unpack it and run it, but malware scanners would not be able to unpack it, to examine it. So you could sneak known malware through. This kind of thing keeps happening. Another one is the extra field length. There's a length field, but it's only a 16-bit value treated as a signed integer. So if you make the length longer than 32,000, it rolls around and is treated as a negative number. So that means you can inject altered files that pass signature verification. You can trick it to ignore some of the data that's coming in. And there's the name field length was another flaw that allowed you to inject code into the file name while passing signature validation. This is what tends to happen when there is some kind of length field and it's misunderstood or wrong. You can get things to read or write past the end of their limits, and you can often gain control of a box that way or disclose secret information. So that's one thing. That's signature verification, what it does for you. Then there's permissions. The Android permission model means that every time you install an app, it'll tell you what permissions it has. This one can see your contacts and use the camera and use the Wi-Fi and so on. And certainly in earlier versions of Android, you just had to accept or you couldn't install the app. I think modern versions will actually let you turn off some of these one by one, but of course if you do, some of the functionality of the app will be broken. And all right. Anyway, the Android manifest is here. This is the main file to control the overall structure of an app. And we talked about it before. We'll look at these in the projects. But all the permissions are in here. Wake lock, access network state, internet, access Wi-Fi state, camera, and so on. Among other things, the manifest lists all the permissions this app has to use features in the operating system. So you can define a new permission. Skype did this, for example. They added a permission called Make Skype Calls, or something like that. It only mattered to Skype. You can have a new feature in the phone, and because you might want to let other apps have access to that. And so you can do that. So Skype defined this one, permission C2D message. That's the permission, and permission has protection levels. When you define a permission, you specify what the protection level is, and this is the signature protection level, which is the most common one and the one you usually want to use. And here's some options. Normal is the default value. It grants this type of permission without asking for the user's explicit approval. All right. Then there's dangerous, which I've never seen really used, be something dangerous. Here's signature. This is the one where if they're requesting application, you can only get this permission in another app if it's signed with the same signature as the app that defined the permission. So if Skype defines some Skype feature, you can only use it with other Skype apps that come from the same company. That's what signature normally does. Another option is signature or system. That means anything with the same signature or anything that came from Google. So you can get in there. And that's why they said one thing you need to know on the phone is you need to know which apps really come from Google and which come from other parties. All right, so the system is part of the Android system image or apps installed in the system partition. There's also something called development that's poorly documented and not commonly used for a protection level. But signature protection is the main one. For normally, you don't really want to share your functionality with another app, so you just make it so only things with the same signature can use it, and then nobody can use anything except your app signed by your certificate. So malicious apps want to have permissions like access to Wi-Fi, access to camera, access to microphone to spy on you. The user might notice that, but they usually don't. Usually you just ask for permissions. User will usually just click OK and not pay any attention to that warning. You can also have exploits. Gingerbreak was one of the kernel exploits. If you can take control of the kernel of Android, you can violate the security model, because then you can be root and you can get in everybody's account. You can change things without popping up boxes to ask the user. So if you get kernel control of the box, then of course all these things, you can just turn them off. So that's And there are kernel exploits that come by every now and then, defects in the operating system, like every other operating system. So the sandbox, this thing called the sandbox that isolates each app from other app, just works by user accounts. So each app runs as its own user. So this app, Coinbase, runs as A145, Schwab runs as A129. Each app runs as a different user on the phone, which is very different than a normal desktop operating system like Windows or Mac. And so you don't have a separate virtual machine for each app. You just have a separate user account for each app. So the separation is enforced by the kernel of Android. That's why I say if you get into the kernel, then you can become root and you can overcome this. Root can just go into any other person's account. They can change permissions and so on. But if you only have one user account, which is what will happen if you get to install one malicious app on the device, you just have control of that one user account that no other app is using, and that's why they call it a sandbox. You can't get at the other apps or the other apps' data. All right, and then of course there's encryption. If you had full disk encryption, this is what you get on Windows with BitLocker. This is how you prevent data from being stolen from a stolen device. So this has been available in Android for a long time. Now, iPhones have got this right. Ever since the 3S, iPhones are always encrypted all the time. So before you type in any passwords or data of any kind, the whole SSD is encrypted. And there's an option in the settings to reset your iPhone to factory defaults, and all it does then is delete the key. So all the data that's encrypted becomes invisible. This is incredibly effective. There was a French company a few years ago that bought 100 used iPads off eBay and iPhones and tried to steal the data off them, and they did not recover any usable data. So the iPhone system really works. The Android has this ability, but it's usually turned off because it drains the battery. iPhone apps have to be very careful of how much power they use. There are strict requirements, and you can't put an app in the App Store unless you're careful. Android apps do not have that. Google has recommendations, but they're complicated and hard to follow, and many developers don't. And I've reported apps to people that just run the CPU at 100% all the time and drain your battery rapidly. This kind of thing keeps happening. So that's an issue. All right. Anyway, another huge problem with Android is that people use really old versions of Android. Most Apple owners use only the later versions of things, but a lot of people are using Android versions that are 5 or even 8 years old or 10 years old. Here's the way it was in 2020. Here's all these Android versions back to Android 1.0. That way 2013, but the green thing is still around, and green is, I think, KitKat. Android 4 was still in use. So a lot of phones are badly out of date, and unfortunately, most carriers don't push the Android updates through. It's only been a couple of years ago that Android finally made 2 channels for updates: security updates and feature updates. They were all treated the same before that, and the problem is many carriers charge money for a feature which Google decides to make free in a later version, so the carriers block the updates. This is a problem. So an enormous number of Android phones have not been updated, and as you know, that's the worst thing you can do for security, because then there are known attacks and you haven't patched them. Right, and so there's encryption. The SD card, if you have a removable SD card on your phone, it's not encrypted. And of course, encryption only protects data at rest. Once you put in your PIN and log into the phone, then everything is decrypted. So an attack that works while the phone is running, like a malicious app, can see right through the encryption. The only point of encryption is when your phone is turned off and somebody steals it, then they can't get your data. That's all it accomplishes. All right. Let's take a look at a Kahoot. I should have these ready in one of these windows. There we are, 6B. All right. Yeah, go to kahoot.it and then put in that number and a name. Good. There's 10 people online and 5 or 6 in the room, so we should get a few here. What's that? Yeah, I remember you liked it last time by the end. Yeah, some people like it, some people don't, you know. It's optional. All right, everybody get in. I'll wait for a couple more measures of this. Looks like we got a lot of people. That's pretty good. Are you coming in? Are you in already? Okay, good. All right, let's give it a shot. Okay, what does an app signature prove? None of those, right. And now a signature on a website, an HTTPS certificate, proves a lot of these, like the real identity of the source, but an app signature doesn't prove any of that. You can make a self-signed app with any fake name you want, and nothing in the operating system will prevent that. All right. All right, so what vulnerability used two files with the same file name in the same APK? That was the master key vulnerability.
Yes.
There's two files. One of them is used to verify the certificate, but the other one is the one that actually runs on the phone. All right. All right. What file lists the permissions an app requires? That's the Android manifest. Lists all the permissions and some other things. We'll show you later. All right. What permission level should an app generally use if it defines a new permission? Normally, you use signature, and then nobody can use it except apps from your company. That's normally what you want. All right. All right, I got Des. RS27AR. All right. So, like I say, make sure we know your real name. You'll have trouble getting your points. And I'm going to stop the video recording.